Hey everyone, let's kind of move on and let's take a look and find the centroid for, we've already done the centroids for areas, but let's look at finding the centroid for a line. And I put lines in quotes here because it's not necessarily a straight line, right? So you might try to find the centroid of, say, a noodle of spaghetti. Before it's cooked, it's a nice straight line, but after it's cooked, it's going to have some arbitrary shape. And I might want to know where is the centroid of that arbitrary shape. And so here's a blue line, and I don't care about the area underneath. I just want to know where is the centroid of this object, or this curvature, if you will. And it might not be on the curve. That's the other thing we want to keep in mind. The centroid does not have to be a part of the object. Okay, and we'll see that later on as well. So there's a very similar definition here. When I go to find the centroid, if I want to know the x bar for this curve, then it's going to be the integral of x dl divided by the integral of dl. Okay, so that's going to give me the x bar, just like I did x dA divided by the area when I was looking at the centroid of an area. I'm going to have a similar thing when I try to find the centroid of a curve. And you can imagine y bar is equal to the integral of y dl over the integral of dl. Same idea, right? Same idea. Now, a couple of things I do want to talk about. This curve is not perfectly drawn, but it kind of has a symmetric shape. And symmetry is a big deal when it comes to centroids. If you have nice shapes, then you're going to find that if there's symmetry, that the centroid will be in the middle of that shape, or wherever the symmetry is nice. And so I could look at this shape here, and it's kind of got this S shape. The centroid's probably right there in the middle. Okay, in a similar situation, if I had an isosceles triangle, I know that the x position of the centroid is going to be in the middle of the triangle because it's symmetric about this y-axis. It's not a very well drawn y-axis, but it's going to be symmetric about that y-axis. Okay, let's try that again. All right, well, we're not going to worry about it too much. So look for symmetry in shapes as well, because that'll be really helpful when it comes to trying to find out where the centroid is. Okay? Okay, so that's how we find the centroids of lines. Now, a lot of the shapes that we're going to be working with, the centroids have already been found. Usually nice shapes. In fact, some really not so nice curves, for example. But we'll find a lot of those centroids in the book. Okay, and in many cases, in this book particularly, the centroids of a lot of nice shapes are already done over here, right? So you can see the centroid of a triangle, quarter circle or semicircle. These are going to be some sort of curves. And then here's going to be the arc of a circle, right? And then here's the centroids of lines, but the line is a semicircle or an arc of a circle. And over here you've got another arc. This, I think, is a quarter circle here, right? There's a quarter circle, semicircle, and then the arc portion of a circle. Okay, and we'll learn in a later video how to find those by integration. But for now, especially with nice shapes, we're not going to worry about it. We're just going to reference the textbook or some sort of a chart. You can do it on the internet as well. A lot of centroids are also charted out for interesting shapes like angle iron or I-beams. They're going to have centroids as well. And I'm going to want to know where the centroids of those shapes are because the center of mass is going to be really very important, or the centroid is going to be very important when we go to bend those or twist those in a course like mechanics of materials. Okay, so that's how we do it for lines or curves. But let's take a look at something else here. Let's look a little bit about what we refer to as the first moment. Okay, and the first moment is actually related to this whole concept of a moment. So let's assume, for the sake of argument, that I've got some arbitrary shape, some arbitrary area, and I'm interested in the first moment of that area. Well, if it's a flat object, physical object, for example, then what I kind of want to know is where is the centroid of this object, or the center of mass of this object. And I showed you on a previous video, at least in one dimension, if I look at the center of mass of a one-dimensional object, I can balance that object on my finger if I put it underneath the center of mass. And the idea here is that the position of the centroid is going to yield a moment of zero. Okay, and so that's where the first moment comes from. But if I want to know, for example, if this is the shape, but these are my axes, so here's the x-axis, and here's the y-axis. If I'm interested in how this object is going to try and move around the x-axis, right? How is it going to? Let's take this and rotate it. And maybe I've got something connecting it to the x-axis that's going to swing around. In other words, what's the moment of this object around the x-axis? Well, the idea here is that this object's got a centroid right there. I don't know whether that's exactly where it is, but that's where I'll designate it. It's going to have a coordinate of x bar and y bar. That's the centroid of this black shape. And what I want to know is what's the moment about the x-axis. And so I'm going to call it the moment about the x-axis. So this is the first moment about the x-axis. And that moment is going to be equal to force times distance, right? But the idea here, if this was a mass, I would say all of the mass was at this point right here. That's the idea behind, the whole idea behind center of mass, or centroid. So in this case, it's the centroid of the area. So all of the area, I'm going to say, is concentrated right here, and the moment's going to be equal to what? It's going to be equal to the area times the centroid, right? It's going to be equal to the area times the centroid, or the integral of x dA. So that's going to be the first, the integral of y dA, not x dA, right? So the moment about the x-axis depends on how far this is from the x-axis, and that's the y distance. That's the distance in the y direction. That's the distance from the x-axis. And so in a similar fashion, the first moment about the y-axis, that's going to depend on this distance, which is the x position of the centroid. And so that's going to be equal to x dA. So the idea here is that this is basically equal to what? It's equal to x bar times a, and this is equal to y bar times a. Right? So I've taken y bar, multiplied it by the entire area, and all of that moment around the x-axis is concentrated at this point, and so it's going to be the area, or if this was a mass, it would be all of the mass concentrated, and that would be the moment about the x-axis, but it would depend on the y position of the centroid. Okay, so that's the first moment. There will be a second moment. We'll talk about that pretty much later in the course, but we'll get there. All right, so talked about first moment, and we've talked about the centroid of lines. If you have any questions, please leave them in the comments below. Thank you.